So in example 7, you're asked to find all values of h for which the vectors -1, 2, 4, 3, 2, 6, and 1, 6, h are linearly dependent. So I went ahead and wrote the corresponding equation here. Whoopsie, I erased part of my matrix. But so recall that vectors are linearly independent if the equation c1 times the first vector plus c2 times the second vector plus c3 times the third vector is equal to the zero vector has only the trivial solution. So the only way to take these given vectors and write them as a linear combination equal to the zero vector, only way to make that happen is for all of your scalars to be zero. That's a trivial solution. So this is linearly dependent if this equation right here has a non-trivial solution. So that's why I set up the equation, and then I went ahead and wrote the corresponding augmented matrix. So it's written as I keep erasing. It's written as a vector equation here, and then I converted it to the augmented matrix form here. Oopsie. Okay. And so the next thing that needs to happen is we need to row reduce this augmented matrix to consider the solution set. So first thing I would focus on is I want to get a 0 in that entry right there. I realize I have a -1 in this diagonal position here. I know we typically like to make the pivots 1s, but that's not a requirement. The main thing here is we want the pivots going down the main diagonal with 0s below it. But the pivots don't have to be positive 1s. So for now, I'm going to leave that -1 the way it is. And the row operation, I guess I'll stick with yellow. The row operation I'll use to get a 0, where I circled that right here, to get a 0 right there. I'm sorry, it's a little late at night when I'm recording this. Would be, so I would do 2 times row 1 and add that to row 2. Okay. So row 1's going to stay the way it was for now anyway. Okay, if we do 2 times row 1 plus row 2, then I'll have -2 plus 2, so that's 0. And then 6 plus 2, so that's 8. And then 2 plus 6, so that's 8. And then 0 plus 0. Now, rather than copy this matrix, again, I'm going to go ahead and write another row operation that'll get a 0 in this position. And so the row operation that'll accomplish that would be 4 times row 1 plus row 3. So I'll have -4 plus 4, that's 0. 3 times this, so 12 plus 6, that's 18. And then, let's see, 4 plus h here. I like to have the variable in front, so I'll write as h plus 4. And then 0 plus 0 in this last position. Okay, so a couple of quick row operations here. I would do 1/8 times row 2 to get... I know I was just going on about how the pivots don't have to be 1s, but I'd rather they be 1s than 8s. And I mean, 1/8 times row 2 gives you a nice clean 0, 1, 1, 0. Okay, and then so we still got this h plus 4 here, and then 0. Okay. So now I want to focus on getting a 0 in this position right here. So to do that, I'll do -18 times row 2 and add that to row 3. Okay. This is really kind of lagging from when I actually write these. Well, that's really, okay, here we go. So it's row 3 that's going to change. So I'm going to copy down. I'm going to carefully copy down row 1 and row 2. A lot of times these mistakes in row reduction are just a matter of like losing a negative when you copy from one step to the next. Okay, so 0 plus 0, and then negative 18 plus 18, so that's 0. And then negative 18 times 1, so that's negative 18 plus this. Let me do a little, I'm going to write that out just to be clear. So it's negative 18 plus h plus 4. So when you combine that, that's h plus 14, right? No, h minus 14. My mistake. H minus 14. Okay. And then, whoops, 0 in this last position because it's 0 plus 0 still. That last column's just going to stay zeros the whole time. Okay, so now we can consider the solution set here. So this thing is going to have only the trivial solution if there's a pivot in every column. So there's already a pivot in column 1. There's already a pivot in column 2. So if this is a pivot right here, then we're done for. Then this thing has only the trivial solution. So we need this entry right here. Whoa, not right now, Google. Go away. Okay. We need this entry right here to not be a pivot. So a pivot, remember, by definition, is the first non-zero entry in each row. So we want this to be 0. That way it's not a pivot. So this thing has a non-trivial solution. If, get rid of this h right here. If, this thing's lagging so much, h minus 14 that we have in this entry right here is equal to 0. So if h equals 14. If h is 14, then this thing's going to be 0 right here. So that means no pivot in column 3. That means that C3, this corresponds to the variable C3. C3 would be a free variable, which means we can form a solution for any value of C3. So specifically just make C3 equal to 1. And that right there means this is a non-trivial solution, because the trivial solution is if all 3 of these guys are zeros. If we have any solution where they're not all 3 0, then that's a non-trivial solution. So these vectors are linearly dependent when h equals 14.